Hi everyone, welcome to another tutorial video. In our today video, I will go over how to merge different detail elevation models into a single one using Python. So let's get started. So in a previous video, I did the same procedure using QGIS. In this case, I'm gonna use Python, and our task is basically read all of these raster files and generate a single one that contains all the data elevation model um, for that specific area. So let me use QGIS to show you the files. So um, those are the files, as you can see, are divided into section, and this is mainly to reduce the size of the file when you want to download, and when USGS is upload them into the website, into the servers. So our goal is basically to read all of them into Python and generate a single one. um, so let's start. So let's go to Jupyter Notebook, and then over here are the files. So in this folder, I'm gonna create a new Jupyter Notebook. Then select over here, let's name it whole detail elevation model. And for this video, we will need to use three main libraries. The first one will be raster. We're gonna use this library to open the files, the raster files. We're gonna use one function from raster called merge. So let's import that function, and also we're gonna use a function called glob to read all the files. So I will show you this later. So let's change this to marked down. Reading raster files. So first, let's go into this folder and read all the files, all these T files, which are the rasters. In order to do this, so we will need to, let's create a function called TIFF files. So we are going to save all the T files into that variable. Then we're gonna use the function glob, and we're gonna specify where the T files are located. So this is the folder, this one over here. And now what we need to do is specify the files that we want to read. So as you can see over here, the files and all the files, and in period TIF. So yeah, with this asterisk, we are basically let Python know that we are going to use this function to read all the files that finalized in TIFF. Over here we can plot them. So you can see, maybe if I use length tab, there are 8 files. So we need to read those 8 files and convert it into a single one. So in order to do this, let's do that in the following cell. So we are going to generate this variable called src files to mosaic, and we're gonna use a for loop to read all the T files. So we're gonna use this for loop to read all the files using raster, and there are like eight files. So we're gonna do 8 iterations with this for loop. So let's first create this src variable that will storage the red T file. So let's use raster, open, and over here we need to specify the file, which is this fp. And then what we're gonna do is to create this. So with this list, we are going to storage each of the file that we are reading. So let's call the list first, files to mosaic by using append, and over here we put the variable. So now if we run this, if we see the length, you will see that the length of this variable is 8, but this variable basically has each of the raster files, the actual raster files. So now what we need to do is merge those 8 files. And so let's create these 2 variables and use this function called merge that we imported before. Okay, so merge, and we need to pass that function receive this variable. Okay, depending on the amount of files that you have, it will take in the resolution. Using just the elevation model 30-meter resolution. Maybe if you are using a 10-meter resolution, there will be a lot of files. Probably depending on your area, it will take more time than this one, just to let you know. And now, if for example, if I print this shape, you will see that the final raster will have this shape, almost 7,000 rows and 14,000 columns. So so now that we have this one, basically has all the information, the array information, and this one's on geo information, geolocation information. So now what we need to do is create the final raster. So in order to do this, so we're going to use out underscore meta. We're gonna use one specific, basically the last file that we read over here, and we are going to copy all the metadata, the projections, and in general it will be the projection, basically all the metadata, and then in the same cell our meta, what we are going to do is the meta and also the general information from the file. But now what we're gonna do is update that file by specifying some information. So let's use quotation mark. You can use double or single and the driver will be, so the file that we're gonna generate will be a T file, a raster file. The height will be technically this number, the numbers of rows. So mosaic shape. So in Python it will be position 0, position 1, and position 2. So it should be position 1. And then the width, which will be the same one over here, but almost 14,000. That value will be the position number 2. And then the transform, which will be like the geodata, some boundary information, basically contains the resolution, where start the latitude and longitude and so on. So, but all of that information was stored in this trans variable, out trans variable, this one over here, the transform will be that. And now if I run it, so we copy and then update the metadata. And now what we need to do is save the file. So let's output the file. It will be called merged detail elevation model 30 meters. It will be a T file, so that will be the name. And now what I'm gonna do is use raster to create that file. So we're gonna use this name. So with raster period open, this will be the name of the file that we're gonna generate. And then we'll need to let Python know that we're gonna use this function to write, basically to generate a file. And we're gonna use this metadata that we updated, this one over here, for this file. And once we generate a file, we're gonna name it as a destination, DEST, and then DEST, let's use the function write, and so it will be this one, mosaic. So as a summary, what we are doing over here is using raster to create this file, merge underscore DEM 30 meters period TIF. We're writing a file, so therefore Python is generating the file with this metadata. And just because we're using width, we're gonna create this and assign it to this variable, the est, and then we're using the write function to save the file, which is this mosaic variable. Okay, so now if I run it, depending on the size of the final file, it will take a lot of time. In some cases, if you're using 1 meter or 10 meter resolution, I'm using 30, and because of my study area, so it basically take a few seconds or a few milliseconds. So now what I recommend you to do, now If we go back, you will see that we created the file, which is this one. But before showing you the file, um, what I recommend you to do is, for these files that we open over here, I recommend you to close them. Okay, so let me save this. Let me go back to the folder. Over here, you will see this was the file that we created. You will see in the preview that is completed. But now if I drag the file into QAS and I hide all the ones, the single ones, and let me just do this, and then if I drag the file over here, now you will see this is the final one. As you can see, even though I used all of them, when you're using this merge function, it basically makes sure that there are some files that didn't have any information. So therefore, it basically put like no data over here. There is no data over here. This is mostly because over here is located the ocean, and these are the islands. So you will see some information over here and over here as well. But yeah, so this is the video. Let me know if you have any comments, and I will see you in another one.